Once God showed me the truth from Genesis to Revelation about creation, I asked the Lord, Lord, people are going to call me crazy. It's going to bring reproach and ridicule and attacks. And it may even run people off who listen to us and get fed. I said, Lord, do you want me to go down this road? And this is what he said to me. Have I ever told you, I heard the Spirit of God say this, have I ever told you to hold back any of my truth? I said, no, Lord, you have never told me that. He said, then you have your answer. And I was like, well, here we go.
What's the circumference of Earth?
Earth's circumference is said to be 24,901 miles.
What about Earth's radius?
To find Earth's radius, you take 24,901 over 2 pi. To find 2 pi, you take 2 times 3.14159, depending on how far out you want to go with pi. Or 2 pi can equal 3.14159 plus 3.14159. So Earth's radius will equal 24,901 divided by 6.28318, which equals 3,963.12059. For number's sake, we will round down to 3,963. So Earth's radius equals 3,963 miles.
I understand, Daddy. That makes sense. You're really smart.
Biblically speaking, the fear of the Lord is the beginning of wisdom, and the knowledge of the holy is understanding. And although I appreciate the compliment, there's still a lot to learn.
Okay, Daddy, I understand. Do you know how to calculate the rate of Earth's curvature?
I created this image to clarify the concept. Let's use the Pythagorean theorem expressed as a squared plus b squared equals c squared in relation to this right triangle. In this context, SW represents the surface of the Earth. W stands for the angle, D1 indicates the distance to an object, and R is the radius. Our main goal is to solve for H1. We know that a squared plus b squared equals the hypotenuse of the triangle. The hypotenuse of the triangle, in this case, is the radius plus H1. As I apply the Pythagorean theorem for the variables, we know that r squared plus d1 squared will be equal to r plus h1 squared. To solve for r plus h1 squared, we will simply use the distributive property. R times r is r squared plus r times h1. Then we have h1 times r plus h1 squared. To write this out formally, we have r squared plus h1 squared plus 2 times r h1. Are you following me, baby?
I'm following you, Daddy. Keep going.
So r plus h1 the whole squared can be written out as r squared plus h1 squared plus 2 times r h1. Now that we have our formula properly written out, we can go ahead and cancel the radius squared on each side. That leaves us with d1 squared equals h1 squared plus 2 times r h1. At this point, we can go ahead and ignore h1 squared as it is much less than the radius. That leaves us with d1 squared equals 2 radius h1. We're going to go ahead and rearrange the formula so it's written as h1 equals d1 squared divided by 2 times the radius. Remember this for later. Next, we will create a relationship between d1 and SW. Remember, W stands for the angle. The tangent of any angle is the ratio of the length of the opposite side divided by the adjacent side. For small angles, in this case, W is equal to d1 over the radius. Since angle, by definition, is arc over radius, we also have W equals SW over radius. Comparing the two, we have d1 over radius equals SW over radius. Now that we know d1 and SW are the same, and we are solving for h1, it can be written out as h1 equals SW squared over 2 times the radius. Considering d1 squared and SW squared are equivalent, we will proceed by using SW squared to solve. The reason we've been focusing on determining the value of h1 is that we want to calculate the amount of curvature drop over a specific distance. Understanding this drop is crucial for our analysis of the observation you are about to witness. Now that we have the equation properly formulated, let's go ahead and solve for a distance of 1 mile. h1 equals 1 mile squared divided by 2 times the radius, known as the diameter. We found out the radius is 3,963 miles, so the diameter will be 7,926. Let's solve. h1 equals 1 mile squared divided by 7,926, which then equals to 0.000126167,045 miles. That amount of miles equals to 7.994 inches. For number's sake, we will round up to 8 inches. Now we know that h1 equals 1 mile divided by the diameter, which is 8 inches. We have h1 equals 8 inches times miles squared, which is more popularly known as 8 inches per mile squared.
Okay, let's go.
Can you elaborate on that more?
Absolutely. Although we did a very minute amount of rounding, it is still known that the Earth should curve at a rate of 8 inches times the miles squared if it had a circumference of 24,901 miles. To solve for that is quite simple. Let's say we have a distance of 3 miles. We square the amount of miles, meaning we take 3 times 3, then times that by 8, that will give us the amount in inches. So we can divide that by 12 to give us the amount in feet. So we have 3 times 3, which equals 9, times 8 divided by 12 equals 6 feet. So in 3 miles, there should be 6 feet of curvature.
What about the distance of 15 miles?
The same rules apply. You take 15 times 15 times 8 divided by 12 equals 150. So in 15 miles, there should be 150 feet of curvature.
Is this rate of curvature provable in observable reality?
I think we both know the answer to that, babe. Now that we know the Earth must curve at a certain rate if we lived on a globe, let's go over some long-distance observations I made in Okaloosa Island, Fort Walton Beach, Florida. My exact viewing location was on the Okaloosa Island Pier. This pier stands at a height of 25 feet above the water. With my Nikon P1000 and its tripod, adding about another 5 feet, we can safely say that my viewing height was 30 feet above sea level. And just to show you, I did my due diligence on what we're zooming in on. We have this observation tower on Eglin Air Force Base. We also have the Navarre Beach Water Tower, also known as the Holly Navarre Water System. We have this group of condominiums, that is this entire group of buildings behind the water tower. just viewed at a different angle. Then we have the Belle Mer condos. The main one I want to focus on is the Sun Dunes condominiums, which are the farthest away from my viewing location. All of these locations were not easy to find on Google Earth because they were flattened out. So I asked Google, how come some areas on Google Earth are not 3D? And the response admits that it's using low-flying aircraft, not satellites, also known as aerial photography. I just figured if there are that many satellites up there, why not take an updated photo? Not that we have issues with satellites, but the real photos of satellites seem to always have balloons attached to them. If you Google satellites and go to images, all you get are computer-generated images of satellites in space. Are you starting to smell a conspiracy here? Let's stay on track. From my viewing position, the Sun Dunes condos is 17.77 miles away. The height of the Sun Dunes condos is said to be 90 to 108 feet tall. For number's sake, we will say these condos stand at 100 feet tall. The great part about the rate of curvature we just learned is that there's a calculator we can use that can factor in the height of the observer. I'll leave a link in the description below. For the height of the observer, or eye height, we will put 30 feet. For the target distance, we will factor in 17.77 miles. Now this will show us how much curvature there should be in H1, which is the target hidden height. As we can see, the target hidden height is 81.6 feet. We should only be able to see the top 18.4 feet of the condos. This isn't adding up. Let's repeat the observation. This next location I'm viewing the condos from is on a boardwalk with an observer height of 15 feet and a distance of 15.52 miles. That gives us the target hidden height, H1, of 77.45 feet. We should only be able to observe the top 22.5 feet of the building. Again, we seem to be observing a lot more. Now, I know what might be coming to mind. If the Earth is flat, why can't we see the bottom of these buildings? The reason we can't see the bottom of these condos is that the bottom of these condos is beyond the range of my camera. We have a limit of sight with the naked eye, but with the super zoom camera it will allow us to see further than we usually could. Even then, objects will always converge into the horizon and start vanishing from bottom up. It took me a while to comprehend the law of perspective and the vanishing point. But after you understand how your eyes work, the truth of your reality will start making a lot more sense to you. The other reason we can't see the base of these condos is that the horizon can sometimes appear optical, especially over water or the ocean. Just like with this sunset over the ocean, certain atmospheric conditions, including air density, water vapor, glare, haze, and atmospheric lensing, will obscure the lower portion of distant objects. As with this sunset producing a superior mirage below it, on another day, these buildings created a similar effect. This is optical, not physical. To put it another way, it's about how something looks or appears rather than its physical properties. The physical properties of large bodies of H2O will always need a container and will always remain level. You will never find someone giving you a conclusion on what scale water starts to convey and convex around an uncontained spinning water ball adjacent to a vacuum, because it is strictly theoretical and not provable on any scale ever. Let's continue with some long distance observations I did here in New Mexico, where there's no ocean to cause these effects. Another great part about doing long distance observations here in New Mexico is its high elevation and very dry climate, which minimizes the effect of atmospheric refraction. But since we're not at sea level, elevation must be accounted for. This observation was conducted in Placitas, right down the street from the fire station. Zooming in on Cabezon Peak, which happens to look like a giant tree stump, but besides the point. The elevation of my first viewing location is 5,867 feet. The bottom of Cabezon Peak has an average elevation of 6,400 feet. Adding 5 feet for my tripod and camera, I'm still 528 feet below the average elevation of the base of Cabezon Peak, so there's no need to account for eye height in the Earth Curve calculator. The top of Cabezon Peak is said to be 7,785 feet, and if the bottom of Cabezon Peak is 6,400 feet, the elevation difference from bottom to the top is 1,385 feet. I hope I'm not losing you guys with all these numbers. I hope this visual helps. The average elevation of the bottom of Cabezon Peak is 6,400 feet. The peak is at 7,785 feet. From the bottom to the top is 1,385 feet. My viewing height is 528 feet below the bottom's elevation, the total equaling to 1,913 feet. The eye height stays at 0. The distance from my viewing location is 41.38 miles. The target hidden height, H1, becomes 1,141 feet. 1,913 minus 1,141 equals 772. We should only be able to see the top 772 feet of Cabezon Peak. No curvature is observed. And just to really shut up the refraction claim, I repeated this observation with an infrared filter. An infrared filter can minimize atmospheric refraction because it helps to reduce the effects of scattering and distortion caused by the atmosphere. Infrared light is less affected by these atmospheric conditions compared to visible light. By using an infrared filter, I can focus on the wavelengths that are less prone to refraction, which results in clearer images and improved accuracy in observations. All data confirms if the Earth curved at 8 inches per mile squared, we would only be able to see the top 772 feet of Cabezon Peak. Yet, we can see the entire mountain, indicating it's visible from bottom up. Let's repeat the observation from a higher elevation. My next viewing location has an elevation of 5,988 feet, with a distance of 41.44 miles, making the target hidden height, H1, of 1,145 feet. From the bottom to the top of Cabezon Peak is 1,385 feet. My viewing location has an elevation of 5,988 feet. I add my 5 feet for my camera and tripod. The difference between the bottom of the mountain and the viewing location is 407 feet, bringing my viewing elevation to the top of these mountains to 1,792 feet. The target hidden height is 1,145. We should only be able to observe the top 647 feet of Cabezon Peak. Again, there is no detectable curvature. Again, with the infrared filter, if you really want to get technical with the math, since I'm about a mile high here in New Mexico, we can add 2 miles to the Earth's diameter, and it will give us 7.992 inches times the mile squared, which is still safe to round up to 8 inches. That one may take a minute to sink in. This is a mathematical analysis that destroys the idea of Earth having a curvature rate of 8 inches per mile squared, and this might be a hard pill to swallow, but it's the reality we live in. And just to really hammer this home,
The pitcher, steroid Santa Claus, kicks and deals. It's a long fly ball going back, and the ball shatters the sky, bringing the ocean itself down into the stadium. Oh, Simpson just broke this dream's reality wide open.
I repeated this observation from an even higher and more distant location. My following viewing location is at an elevation of 6,100 feet, 43.43 miles away, yielding a target hidden height of 1,257 feet. If anyone's curious to check out the location of this next observation, it's in Santa Fe, New Mexico, at the Arroyo Hondo Open Space Trail. Shout out to my good friend David Gordon for finding this spot. It's a bit of a hike, but once you get to the top, you can observe the peak of the Manzano Mountains from just under 80 miles away. What was interesting about this was that you could barely see these mountains with the naked eye. But with the infrared filter, you can see the mountains from bottom up. The bottom of the Manzano Mountains has an average elevation of 7,142 feet. The highest peak in the Manzano Mountains is 10,098 feet above sea level. The bottom to the top of these mountains stands at 2,956 feet. My viewing location has an elevation of 7,300 feet. I add 5 feet for my camera and tripod. That puts me at 163 feet above the bottom of the Manzano Mountains. We'll factor in the eye height at 163 feet. The target distance is 76.96 miles. Which implies a target hidden height, H1, of over 2,500 feet. We should only be able to observe the top 449 feet of these mountains. But again, there's no observable curvature obstructing our viewing from nearly 80 miles away. By now, your mind might be scapegoating to other asinine ideas like, what if the Earth is a lot bigger than what they tell us? It has to be a globe, right? I've been indoctrinated with that since I was a baby. Let me explain how illogical that is. The entire heliocentric religion is based on the Earth's radius being accurate. If the Earth's radius is larger than what they tell us, the circumference would have to be much larger. If the circumference is larger, Earth's spin would have to be a lot faster. This would result in the orbit having a different speed. In other words, we wouldn't have 24-hour days, nor would a year amount to 365 days. The accuracy of the radius is the foundation of this lie. This is the reason I'm not using the Walter Bislin's Advanced Earth Curve Calculator. There is an interface controller for refraction, but raising the refraction increases the radius. If the radius is off, the entire heliocentric delusion collapses. I'm not finding flat spots on a globe because there needs to be consistent curve throughout the whole Earth. Otherwise, we wouldn't see a perfect circle during a total lunar eclipse, which also completely refutes the idea of Earth being an oblate spheroid. If you think lunar eclipses are proof that the Earth is a globe, you're going to have a hard time learning about the Selenelion Eclipse. It's a lunar eclipse that occurs when the sun and the moon are both above the horizon. If both celestial bodies can be seen simultaneously during a lunar eclipse, then the Earth's shadow is not the cause of the lunar eclipse.
Ron shot this footage from Chipley, Florida on January 31st, 2018. On that day in Chipley, the moon set at 6:34 and the sun rose at 6:34. So both sun and eclipsed moon were on, or at the very least at, the horizon at the same time. So here's Ron on the Terminator line in Chipley, Florida, and here's his sun, Earth, and eclipsed moon in a geometrically straight line in space, 180 degrees apart in the sky, in a perfect syzygy alignment. And Ron is able to experience both sun and eclipsed moon on his horizon because he's actually seeing them in the refracted positions, right? But did you notice that Ron's moon wasn't fully eclipsed? It was in the process of eclipsing, from the top down no less, at the time it set in Chipley. So let's add in the Earth's umbra, which is said to be 2.6 moon diameters wide at the point the moon crosses it, and see how that works in this view. As it turns out, Ron's moon set at 6:34 in Chipley, 52 minutes before peak full moon, which wasn't until 7:26 a.m. Ron's time. So the reason Ron's moon was only in the process of becoming eclipsed when it set is that the actual position of the moon at that time wasn't here, but here. And it's going to take one heck of a lot of dip angle and refraction for Ron to see the moon set from his Terminator line when it's still an hour on the other side of peak full.
Now take a look at this time lapse of this moon, where both the sun, again this is the sunrise, the sun and the moon are both above the horizon. Look at the top portion of the moon, it's darkened. Again, going back, put pause here for a second, going back to this model. Top portion should be illuminated, of course, and the bottom portion darkened, and you're not getting that. You're getting the exact opposite, okay? Play this again. You understand what's taking place here. So this definitely proves this is not caused by the so-called ball Earth.
The most common explanation of lunar eclipses on a flat Earth is that an unseen celestial body blocks the moon's self-illuminating surface. You know, kinda like a new moon and a solar eclipse. A heliocentric lunar or solar eclipse would cause a three-body problem to begin with. It is physically and scientifically impossible to have more than two bodies of mass orbiting each other in observable reality.
In the 300 plus years since Newton, no one has been able to find such a method. There is no general solution to the three-body problem.
It's called a three-body problem for a reason. The three-body problem also gives the most acceptable theory of gravity of the bending of space-time huge issues. The only applicable visualization of the bending of space-time I can think of is the circular spandex with the weight in the middle. This analogy illustrates how mass influences the fabric of space-time. While two spheres can orbit each other in a stable manner, introducing a third mass complicates the dynamics significantly. And speaking of problems, for those who believe in outer space but then believe in a young Earth, you have what is called a distant starlight problem. If the stars are light years away, it would have taken billions of years for the light to get here. A young Earth needs local stars. You can't have it both ways. You need the Big Bang cosmology for the Big Bang. The scientific absurdities of the globe still continue to amaze me. And for those who haven't seen, I was able to zoom in on Mount Taylor from 98.9 miles away from Sunrise General Store in Santa Fe, which was missing 1.24 miles of curvature.
One of the things you can see yourself with a pair of binoculars is if you actually go out to a lake and there are boats on that lake. The farther away a boat is, the more the bottom of the boat will disappear, and you'll basically just see the mast of the boat. And as a boat goes farther and farther away, the last thing you will see is the very top of the mast of that boat. And that's because the boat is actually going over the horizon that's curved. You can see that with binoculars. By an ocean, by a lake. It's really easy. That wouldn't happen if the Earth were flat.
I won't be spending too much time on this observation since it is common knowledge in the truth community. Boats do not go over Earth's curve. Globe believers need to understand that the illusion of a ship crossing over Earth's curvature is actually the result of a ship's angular resolution becoming compressed at the vanishing point, causing convergence at a distance. I've sat on the beach with my Nikon P900 doing this observation multiple times. The horizon, you know, the flat and level line where the sky and Earth meets, is the vanishing point, not Earth's curvature. Once you can wrap your head around that, all of the other puzzle pieces will start coming together. Also, if there's an obvious curve on the y-axis of a sphere in just a few miles, there would need to be an even more obvious curve on the x-axis within just a few more miles. That is not what we observe. There are other ways you can measure Earth's x-axis as well. If this handrail is flat and level, then you can bet that the horizon behind it is perfectly flat and level as well. The other issue that boats going over the curve is proof that we live on a spinning, orbiting, uncontained ball in outer space is that if that's where the curve is, that's where the curve is going to remain, as you can see in this demonstration here.
What you're watching right now is a computer simulation of the globe, showing how much curvature should be visible and what curvature drop would happen as you increase altitude from 0 feet all the way up to 329,400 feet.
Also, an aspect to take into consideration. Under visual flight rules, VFR conditions, when the weather is clear and the horizon is visible, pilots rely on the natural horizon as their primary reference, aligning the aircraft's nose with a specific point to maintain a straight and level flight.
So your attitude direction indicator, that's that guy right there,
you
right?
see that? Yeah. The quantity right now is at 0. So yeah, normally if you're flying, it'll be pitched up like 2 or 3 degrees to maintain level flight.
Okay.
Yeah, so it's an angle. Yeah.
Pilots rely heavily on the ADI for maintaining straight and level flights. The attitude direction indicator measures the orientation of the aircraft relative to the horizon. A gyroscope maintains its orientation regardless of the motion of the vehicle it's in.
In inertial guidance systems, you have a spinning wheel. But that spinning wheel is mounted in such a way that you cannot put a torque on the axis of rotation of the spinning wheel. That's the way it's mounted. We call it 3-axle gimbaled gyros. So the moment that you put a torque on it, the housings, in this case the yellow and the black housing will start to rotate, and you never manage to get that torque on the spinning wheel. You never get it on this axis. And therefore, if now you put it on your boat, or you put it in a plane, a missile for that matter, if you can never put a torque on the spinning wheel, and if the angular momentum for spin is in this direction, it will stay there forever and ever. And if then the plane turns, the direction of the spin angular momentum will not change. But what will happen, of course, is that this yellow frame will rotate, or this black frame will rotate. And in these bearings here are shaft encoders. And they sense the rotation that the outer housing makes in order to keep this thing pointing at the same direction. And that signal is being fed back to the automatic pilot, and that keeps the plane flying in the direction that you want to. That you cannot put a torque on it even when the plane changes direction. And I want to show that to you. Okay, this is the direction of my spin angular momentum. And I'm the airplane. And I'm going to fly. Look at that spin angular momentum. It has no respect for me. It stays in the same direction no matter how I fly. And the error signals that come from the bearings of the yellow housing and the black housing, those arrow signals are fed back to the automatic pilot, and so the plane will stay on course.
Think about this. An airplane that flies at 37,000 feet that uses an ADI to maintain a straight and level flight for thousands of miles can still use the horizon as a reference point. But you think boats are going over a curve at sea level. Do you really think that's logical? And not to beat a dead horse here, but the Blue Origin back in 2016 was able to see the horizon perfectly flat and level at 62.4 miles high. I'm excited to share this last set of observations with you. It's an aspect that completely destroys the globe religion that the truth community needs to be aware of.
If you're at a northerly latitude facing northwards and you watch the stars for a while, you will notice that they appear to rotate counterclockwise around a point in the sky. This point is roughly aligned with the star Polaris, which we call the North Star. If you were to then travel south for a while, and at the equator, all the stars move directly east to west through the sky. Then heading towards the southerly latitudes and facing south, you will see a whole new batch of stars you couldn't see in the north, and they will again be rotating around a point in the sky, though this time clockwise instead of counterclockwise.
There is no need to depart from the northern regions of Earth to witness the stars rotating in a clockwise direction. Likewise, there is no need to travel to the equator to observe their east-to-west motion. The celestial patterns can be observed from here in the north. Let me explain. This star trajectory was over in Pagosa Springs, Colorado, pointing my camera south. We can see the stars are going clockwise. This next time lapse was in Fort Walton Beach, pointing my camera south. And again, you can see the stars going clockwise. I repeated this one here multiple times. And over here in Rio Rancho, New Mexico, again with my camera pointing south, you can observe the stars rotating right in a clockwise rotation. You might ask, why are we getting this effect in the northern hemisphere if it's supposedly proof we live on a spinning planet? Well, first of all, this cannot be used as a proof of a spinning globe if it's not subject to the latitude of the observer and can be observed in different locations on Earth, especially if we can observe the stars going right in a clockwise rotation north of the equator, pointing the camera south. If we are standing outside looking directly up, our eyes will reach a limit. We can't see forever. This is referred to as the zenith. The zenith relates to the point in the sky directly above the observer. If you're able to observe the horizon doing a 360-degree spin, that would be considered the azimuth. This is how Celestrail Navigation works. You need a flat horizon to use a sextant. A flat horizon is necessary because the sextant measures the angle of elevation from the horizon to a celestial object, and a curved or obstructed horizon makes this measurement unreliable. Why a flat horizon is essential. Angular measurement. A sextant measures angles. The angle is calculated from the horizon, which is considered a flat horizontal line. Accuracy. A true flat horizon allows for a precise reading of the angle between the celestial body and the sea, which is critical for accurate navigation. A distorted or curved horizon would lead to inaccurate calculations and a wrong position. In addition to a flat horizon, we also have this field of vision around us that some refer to as the celestial dome. Again, this is how celestial navigation is measured. This is what creates this effect of the stars going in a clockwise rotation here in the northern regions of Earth.
You how are you getting the sky to rotate in opposite directions depending on where you're standing? Let's start with there. How observable is that? How does that fit here? In the north you get counterclockwise rotation, in the south you get clockwise rotation. Explain that to me on your default flat plane. Explain it.
Just looking opposite directions would make them go the opposite directions. They all go east to west. You don't get it.
Right?
You don't get it. The stars drop due to perspective, so we're actually looking out towards them, not directly up.
Which depends on your latitude, right? Depends on your latitude. If you're at the equator, they're going from horizon to horizon.
This is another time lapse I did over here in Rio Rancho, New Mexico, pointing my camera about 237 degrees southwest, tilted up at about a 45-degree angle, proving you do not have to go to the equator to get this effect.
Wait, do you agree that if I was looking out and something was spinning one way and then I looked at it from the other direction, it'd look like it was spinning the opposite way?
No, it wouldn't. It wouldn't.
Okay.
As you can see, these light beams move left in a counterclockwise rotation, diverging outward. When I look in the opposite direction, they rotate right in a clockwise rotation, converging inward. This is a prime example of how our celestial dome causes lights to appear to rotate in different directions, depending on where we are looking. It's also a great example of crepuscular and anti-crepuscular rays. Just to show you how this is possible with this demonstration, my daughter rolls the PVC pipes in one direction. If this were looking south, they go in a clockwise rotation. Then, pointing north, they go counterclockwise. Here's another time lapse I did in Rio Rancho, New Mexico, pointing my camera 124 degrees southeast, witnessing the stars going from east to west. Again, no need to travel to the equator to witness this happening. When we do go to the equator to witness a time lapse of the stars, we can still see the North Star Polaris. Okay, think about this critically. I mean, for yourself. Don't let your indoctrination think for you. Develop your own opinion on this. Imagine being on a spinning globe, you know, like being so sucked out of your skull that you can't comprehend reality to the point you conform to sun god worshippers to form your matrix for you. I digress. Imagine being at the equator on a globe, looking up at the stars or even at the horizon. Even if you had a wide-angle lens that could see 180 degrees, do you really think it would be possible to see Polaris? The only way this is possible is on a flat Earth with local stars, understanding perspective, and recognizing that objects appear lower as they get further away. I verified that stars rotate in both directions in the southern regions of Earth as well as the north, thanks to a good friend in South America. When it comes to the center point of rotation in the southern parts of the world, the southern star Sigma Octantis can't even be observed because its magnitude of 5.42, and it is not a practical navigational star because of its low visibility. The center point of rotation is only possible within our celestial dome of vision, which is personal to the observer. I'm just blown away by how manipulative the globe religion is. They use the star trails as proof of Earth's curvature and motion, when in fact, it is the exact opposite. Take this into consideration. They say we see star trails because of Earth's rotation. But what about the trajectory from Earth's elliptical orbit, its axial precession, or the corkscrew path it follows around the sun at 500,000 miles per hour? Is it really believable that the only visible effect we observe from the star trails is from the least significant motion the Earth is supposed to be doing? The Georgia Guidestones, which was suspiciously destroyed in July 2022, the Antikythera mechanism, the astrolabe, and archaeoastronomy all demonstrate the constellations have remained in their unchanging pattern since the beginning of star history. But we've been told the solar system is doing this. Remember, it is in the north where Lucifer wanted to ascend into heaven to exalt the throne above the stars of God, but instead will be brought down to hell in Isaiah 14:12-15. It is in the north where God stretched out the empty place and hung the earth on nothing in Job 26:7. And the northern lights just happen to radiate the same colors as the throne set in heaven as described in Revelation 4:3. The way the Bible describes Earth is this, and this is what they are hiding from us. They don't want you to know that God is in heaven and has been right above us the entire time.
My ability to go grill a beat is from Elohim. Ain't no competition in my game, it's just me on me. And this composition ain't for fame, it's for G.O.D. Tell the devil, go back where you came, cause we walking free. Hop on the stage and I'm ready for war. I'm not the same person I was before. I see revival breaking on the floor. I pray it makes its way out of the door. In Jesus' name we breaking out of Hades. I might be doing this until I'm 80. I leveled up all the way just to say that ain't how you start, it's how you finish. How you feel like 9 to 5, we stand on business. Just to catch up, you gon' need a village. Okay, we got no limits, huh? We got no limits.